Hello, welcome to my presentation, and thank you very much for coming, for attending. My name is Jędrzej, and I work at CERN, and today I would like to talk a bit about the architecture from the perspective of its maintenance. So what can we do throughout the lifetime of our application, of our project? What can we do to persist its shape so that the project doesn't turn into a big ball of mud. So for that, I would like to show you a library that I have employed here in one of CERN's projects, ArchUnit, which is exactly meant for that, to write some tests about the architecture and to make sure that it's clean throughout the lifetime of the project. Okay, so what are the use cases of ArchUnit? The main objective of the library is to enforce some architectural patterns, a style, an architectural style that we have chosen for our application in such a way that it is always being done, it is always being verified during our tests. So when we are testing the application, for example, during the pipeline, we ensure that the architecture is not violated. So our assumptions about the architecture are not violated. The next thing that we can use ArchUnit for is to write assertions about dependencies between classes or between modules. We can make assertions about the dependency or lack thereof on a third-party library and so on. We can also use ArchUnit. We can also leverage it for enforcing conventions throughout the applications, be it naming conventions, conventions about locations of some classes, and so on. So you can see some examples further on. And as I have already mentioned, the last point is making sure that this is part of your pipeline. So what differentiates ArchUnit from, for example, Sonar or code review is that it's automated as opposed to code review, and it runs as a part of the pipeline, and it fails tests if something is violated, right? So I think we all know how easy it is to somehow circumvent the quality gates of Sonar or maybe not look at them and so on. But here we just enforce how the architectural style should look like in the project, and whatever violates this rule, rules will not be merged into our main branch. And here in the first point, I have also hinted about the documentation. What I mean by this is that we can think of tests as documentation for our project, right? So whenever a newcomer comes to our project, you can take a look at the tests to see what are the use cases of our code, how can you use it, and so on, what are the workflows. And the same thing we can say about our architectural tests with ArchUnit. We can just read them, and because they are written in a fluent manner, it's easy and it's very easy to read them, and then we can make some we can learn about the architecture of our application by reading those tests. So those are the main objectives of the library, and this is actually everything when it comes to the presentation, because I have prepared a demo to show you how this library is used. So what I have here is a Spring Pet Clinic project. If you know Spring, then you might have come across this project. It's basically a very simple demo project that you can use. That was actually written by Spring maintainers to showcase the the use cases and the features of Spring. So there are a couple of those pet clinic projects for different projects under the Spring umbrella. Here I have Spring Pet Clinic REST, which simply shows how you can use Spring MVC for any kind of application. If you're curious about the domain, it's just a project that a vet clinic can use to manage owners, patients, and so on. But this will not be our main topic of discussion today. And what I wanted to point out before we begin is that I have two additional dependencies apart from what was already here. The first one is JMolecules. This is a small library with some annotations that you can use to document the architecture of the application. I will talk a bit more further in our discussion, so you can see how this can be used. This is, of course, optional, and our main or the hero of our presentation, so ArchUnit for the test, and I have fetched all the dependencies, so we can start coding our tests. Maybe I will enter a presentation mode so that it's easier for you to see. Hopefully it will let me. Okay. Sorry about not showing it earlier, but there was not much to show anyways. So what I have is JMolecules and our ArchUnit as additional dependencies, and the rest of the project is pretty much unchanged. So let's start by creating a test class, and I will simply call it architecture tests. You can come up with a more creative name for this class. And let's start writing some tests. Okay, I'm sorry about the namings. You can come up with better ones. I know test is not a good name for a test, but let's not waste our times for that. This is not our main concern here. And here in my presentation, I have noted a couple of things that I wanted to show you. So first, we would like to make some assertions about dependencies between modules and so on. But before we begin writing any rules, we need to have some classes that we can work on, right? And ArchUnit comes with this class file importer that we can use to scan some packages, the class path, or whatever we want that we want to write assertions about. So what I'm going to do is I'm going to import packages of, and here I'm just going to write pet clinic application. Okay, so it's a bit slow today, but we'll manage. Why am you? And let's make it a constant. Why am I making why am I making it scan pet clinic application? Is because it's our entry class of Spring, which means this class is on the root package of our project, and what ArchUnit will do here is it will scan this package and all the sub packages, so it will go through the entire tree to fetch our classes to make the assertions. And we can see that this project is divided into some layers, right? So we can see that we have a REST layer, repository layer, model layer, and so on. So we can, for example, make sure that there are no dependencies from model to repository. So in other words, that the model does not depend on the repository. It should be the other way around. I think this is well, we can all agree on that. And to write this, we can say no classes. This is this nice entry method of ArchUnit that we can use to write our assertions in fluent manner. So what can we say? We can say that no classes that reside in a package model should depend on classes that reside in a package repository, right? So you can already see that it's pretty easy to write and also to read, because thanks to this fluent style of writing the assertion, it's pretty readable, right? So let's call it a rule. And maybe one more thing that I wanted to point here is that I'm using this sugar syntax, this sugar style, to notify ArchUnit that I'm going to use this model package. And I have already gone through the application, and there will be no surprises. So you can trust me that this package model is the only package that is called a model within this application, and the same goes for repository and other packages that we'll be using. And now to test our project, we can say rule check Java classes. And let's try to run this test. Okay, this may take a second. It shouldn't be that long, but since ArchUnit is scanning all our classes, it needs a bit of time to create this graph of the dependencies and so on in our project. And it's not only the classes, but also members of the classes. So you can see it can take a short minute. But we should see, yes, we can see the result now. And we can see that, okay, there are no such relationships. So I guess it's good. But just to show you that, well, I'm not, it's not fabricated, let's say. I will show you how this test could fail. So let us introduce some pathological dependency here. Let's say that, for example, our owner will depend on owner repository. So I have created a field owner repository in the owner class. And now I'm rerunning the test. Oh, I'm sorry. And this should hopefully fail. In the meanwhile, because I had some text, let me just fix one issue. Okay, so we can see that our rule was violated. And let's take a look at this exception message. We can see that it says architecture violation, priority medium. So this is the default priority that we have given this rule. Well, it wasn't us who has given this priority. We can change it anytime, but this is not so important right now. And it says, rule no classes that reside in a package model should depend on classes that reside in a package repository was violated. And it says there was one violation. And then it gives us a list of violations. It says that the field owner repository of the owner class has the type owner repository. which obviously is a violation of our rule. So we can see that this indeed works and tests our architecture. Also, maybe if you're worried, if you're actually testing anything with your ArchUnit test, I can tell you that the default behavior of ArchUnit is to fail if no classes are actually checked. So you can see that there are two parts of our assertion. The first one filters out all the classes in this case, but it could be any other code unit. And the other part is the actual assertion. So if there are no classes that pass all the filters, ArchUnit should throw. And it did throw. It says that no classes reside in a package mode. So you can see that I have introduced this this typo here to show you that if we make a mistake in naming packages and so on, and nothing actually is taken into consideration in our test, then it will notify us. Okay, so we have seen that this dependency check works, and we have checked the dependency between the layers. This project is too small to be modular, so I cannot test any dependencies between the modules. But well, you can do this in the same way. You can think of it analogously, right? So it could be that the model is one module and the repository is the second module, and we want to make sure that the dependency is only in one direction, right? So there is no dependency on model, from model to repository. And that was our first point. The second point I wanted to show you is annotations. So let's maybe take a look at our model. Let's go to the owner class again. And as you can see, our owner class has the annotation table, right? Which is not mandatory for JPA, but there are cases when it is useful. Maybe we want to make sure that this annotation is always there, so that we are documenting our schema in a proper way, right? So we can write assertions for that as well. This time we want to say no classes, but instead we will use classes, which simply means that all the classes that are annotated with entity should be annotated with table. And I will use this Jakarta because there are a couple of table annotations, and we of course mean both annotations from Jakarta. Okay, and now I'm running this test. So what I said here is that all the entities, so everything that is annotated with entity, should be also annotated with table. And let's see if our test passes. Let's see if indeed that's the case for all the classes in this project. So indeed it's that's how it is for every class. Now if I comment it out and I run the test again, now since there is no table annotation here, it actually should throw. Yes, and we can see the exception. So I will not read the entire rule here, but it says that class owner is not annotated with table. So that's exactly what we have here, right? There is this annotation missing. And maybe let's take a look at one more example of that. And I have seen that if we take a look at the controllers, this project has cores configured, but not globally. Instead, using the annotation. So on a REST controller level, we are configuring our cross origin. Well, maybe we want to make sure that it is always the case that we have always cores configured for our REST controllers. And this will be, well, analogously, right? So we will exchange only those two annotations. We will say that all REST controllers, so every class that is annotated with REST controller, should be also annotated with cross origin. And now if we run it, this one I think should pass because I think everything, all the classes in the controller package are configured properly. Yes, so our rule is passing. Let's try what happens if this annotation is missing. So I will drop it and rerun the test. Now it should show us this one violation. Okay, and it says owner REST controller is not annotated with cross origin. So this is what we wanted to assert, right? So as you can see, it's not only about the architecture, it's also about some conventions, about some configurations and so on. So there are many things that you can write assertions about using ArchUnit. The next one is containment. Yes. So sticking with the controllers, maybe some of you have noticed, especially the more experienced ones of you, that the controller keyword or the controller suffix is pretty loaded in object-oriented programming, especially in the days when the REST was not that popular. There were controllers which served as some kind of services. So if we wanted to create a service, but we didn't want to name it a service, then the controller was a go-to keyword together with manager on how to name such a class, right? And this might come as a confusion to many people, especially people who are used to the fact that the controller is a REST controller. That's how they associate this suffix, this keyword. And maybe we would like to create a rule that will get rid of this ambiguity, right? We can say that, for example, everything that has this controller suffix should be a REST controller. And we can easily do that by saying that all the classes that have simple name ending with controller should reside in a package REST and its REST controller to be precise. Now let's try to run it. Yes, I'm sorry, these tests are taking longer than regular unit tests. This is also why I have hinted that you can use these Java classes as a constant, because if you're writing multiple tests, then maybe it would be nice to only scan all these classes once, because this is actually what's taking most of the time when running these tests. But coming back to our test, we can see that it works. So all the controllers are actually in the controller package. Now, if I come up with an idea of creating a second clinic service, but since this name is already taken, I will create a clinic controller. And if I rerun this test with the new clinic controller in the service package, let's see what it does. And it fails, and as we can expect, class clinic controller does not reside in the package REST controller. So this is basically what we wanted to assert here. Well, we can do it in many different ways. Instead of writing where they should reside, we can also say that they should be annotated with REST controller. This should also work. Let's try this one. Well, the idea is the same, right? But the way how you write those rules, you can you can be very creative in coming up with ways how to frame some things about your architecture, about your coding style, and so on. Okay, so this works as well. We can use this one also. The next one will be writing assertions about hierarchy. And for this, I would like you to take a look again at this owner class, maybe not the owner class, but we can see that the owner class extends person class. If we go to person, it extends base entity. Let's see what it does. It's just a mapped superclass, so this is it contains some fields common for all the subclasses, and we can see that it has an ID, an integer, a getter, setter, and some utility methods. So you are probably familiar with this kind of workarounds. I don't know if it's workaround. It's just making this boilerplate that libraries like Hibernate and so on impose on us, making this boilerplate a bit more bearable, a bit more controlled. We know that every entity should have an ID. So what we can do is we can, well, simply create a common superclass with an ID and simply extend it everywhere. This way we just save ourselves from typing this information everywhere. And we can write an assertion about this as well. So maybe we want to make sure that every entity is a subclass of a base entity. So what can we say? You probably can already write this for me, but I'm the one with the keywords, so I will continue. Let me write that all the classes that are annotated with entity should be assignable to base entity. Okay. Maybe you didn't expect this method to be called this way. We have be assignable to and implement. So there are two ways to assert about hierarchies. Implement is, as you have already figured out, for interfaces, and be assignable to for classes or abstract classes, well, classes in general. Let me run this test so that we don't need to wait. And this way we're making sure that every entity is actually a base entity, so it can be cast to base entity. Let's see at the result. Yes, and we have a result, and it actually failed. So what does it say? It says that class user is not assignable to base entity. All right, let's take a look at this user class. And indeed, we see that it's just a class without any superclass. It extends object. And it does have its own primary key. But maybe it's good. In some cases, we would like to use a natural key. Maybe we know that this natural key is unique. It always will be unique, or whatever, if we scale our application or introduce some new features and so on. If we evolve our application, it still will fulfill this purpose of a primary key. So maybe we want to use a natural key instead of a surrogate key in some cases. So sometimes it's good to add some exclusions here in our tests. And how can we do this? I have already hinted to you that we may want to exclude this class. So what we can write is that all classes that are annotated with entities, so all entities, and do not belong to any of, and here we put our user class, should be assignable to base entity. And this should work. Let's run it to see, but you might already be disgusted about the way I have written this exclusion. And you would be right to feel this way because it's not extensible, it's fragile, right? Because whenever we introduce a new entity that will have a primary key as a natural key, then we would have to add this exclusion. So, well, very rarely this is the way to go about this. So let me drop this. But maybe we can document our entity in a nice manner. So we know that there is this rule that all the annotations should have this surrogate key unless we know exactly and we are aware of the consequences of that an entity has a natural key. And how can we say that this is our conscious decision and we are ready to live with the effects that it will have? One of the best ways is to use an annotation to document our decision, to document our architecture. And here comes this J molecules that I have already mentioned. J molecules comes with a handful of annotations to document some architectural concepts in your project. So here we can see this is a domain-driven design related annotation. So this is an identity of an entity. And if I were to be strict about this, I would probably also have to say that this is an entity in domain-driven design understanding of this keyword. But by writing identity, I know and I tell everyone else in my project that this is the natural key that should be used for this class and not the surrogate key that we have seen in our base entity. And how can we now write this exclusion? You may be a bit confused about what I'm going to write, but you will see why I'm doing this in a second. I will write it the other way around. So what is also nice about ArchUnit is that it comes with with a concept of a described predicate. Described predicates are like small building blocks that you can somehow stack together to write more and more complex rules about your architecture. And there is a concept of something that can be annotated. So this is anything that can have an annotation in ArchUnit. And it has some predefined rules. So what I can say here is, let's have something that is annotated with this identity that I have already used. And I will call it is natural key. This will be a nice name. I will introduce a static import so that it's easier on your eyes. And now we can see that we have this described predicate that says that something is a natural key. It simply is anything that is annotated with identity. So it can be a field, but it can also be a getter, right? We can also annotate a getter with ID and with identity. And now, what we actually want to use is a class. We need an information about the classes that have this natural key. So in the same manner, we can say Java class. And that should be the one. And it also has some predefined rules. And here we can say, now we have a predicate for all the classes that contain any member that is a natural key. So you can see I have used this predicate in my new predicate, and I will call it has natural key. All right. So now I have used this smaller building block to build a larger one to say that to describe everything, every class that has an identity, right? And this is it. This is what we need. And now what we can say in our rule that all entities, so all classes that are annotated with entity, should be assignable to base entity or should. And here, well, you can see ArchUnit expects from us arc condition, but we have a described predicate, but this is not a problem because arc condition has this nice from method, the static method that simply converts a described predicate to what we need here. Okay, I will call it have a natural key, but you can come up with a more creative name or simply use it inline, let's say. And now I can just say have natural key, and you can see it all compiles. Let me run the test while I'm talking. And just take a look at how nice it is to read it now, because we say that classes that are annotated with entity should be assignable to a base entity or should have natural key or a natural key if you want to be super correct when it comes to the language. But you can see that you can write the rules just as if you were writing a book. It's so easy to read this kind of rules. And now it works, right? We have no awful exclusions, exceptions, and so on. We can simply enjoy our well-documented identities in our entities. So this is what I wanted to show you. Also, well, about the hierarchies, but the main idea of this exercise was to show you how to use those tiny building blocks to compose more and more elaborate rules about your architecture. I'm using those as fields, as variables here, but you can make them constants and reuse them in many other places. This could come in handy. Okay, and the last thing that I wanted to show you is how to assert some architectural patterns. I know this is what we've been doing most of the time right now, but There are some architectural styles that are very well known, very warm, and so on, and everyone knows them, right? ArchUnit comes with this architectures class, which has, well, right now it's only layered architecture and onion architecture, but those are very useful in writing assertions about this kind of architecture. It's simply a syntax sugar to what we could have achieved using other tools that I have already shown you. This is just a nicer way to frame it. So what we can say, this is clearly a layered architecture, what we have here, yes, considering all dependencies. And now we can define some layers in our application. So let me fold these. Okay. Let's start with the REST layer. And I'm saying here that the REST layer is defined by, and now you can see that it expects from me either a described predicate, like I did earlier. So I can say, for example, annotated by REST controller, but I can also simply give it a package name. So I will say it's REST controller, like this. The next layer will be service, defined by, well, it resides in a service. This is a no-brainer. And let's put another one. This will be, say, persistence, defined by, and what it will be? It would be repository. And now we can write some assertions. So we can say where layer, and here we can put REST, and okay, we can make this constant so that we do not, okay, we didn't change this one. We can make those constants so that it's easier to read and we don't make mistakes. And we can say that where layer REST may not be accessed by any layer. And this is what is expected, right? We don't want anything to use the REST layer because this is just a server application. And those are our endpoints, right? Next, we can go for this service layer. So where service may only be accessed by layers, and this constant will come in handy here. So now what I'm saying is that service layer can only be accessed by the REST layer. Now the last one, let's take a look at our persistence. It may only be accessed by service. Okay. And let's call it a rule again. And let's look, I didn't touch this one, but it's used in the same way. So you can see it's pretty consistent across all the ways to write the rules. And I will run it. And now as the tests are running, I also wanted to just mention one thing. And notice that I'm saying that persistence layer can only be accessed by service layer, which means that it cannot be accessed directly by REST layer, only indirectly through service. This is only what I wanted to notice here, because this is a pretty common anti-pattern that the REST layer uses persistence layer for performance reasons, because we know that calling one method is the load on the performance, which clearly is not, as you have already probably noticed. It's probably, unless we're Google or I don't know, Amazon or something, then this shouldn't be the case. So we can stick to our clean architecture here. And we can see that it didn't pass. What do we have here? Oh yes, I remember some method in exception controller advice calls a constructor of binding errors response. Let's take a look what's going on. So this binding error response is in the controller package. So in our understanding, it is a part of the REST layer, and this advice is here. So it violates the fact that the REST layer cannot be accessed by anyone. And well, this came to quite a surprise to me, because I wouldn't expect anything but the REST controllers in the controller package. The easiest way to do this, to fix this, would be to probably move this binding errors response, which looks like some kind of a DTO, to a different package. But I will not do this, and you will see why a bit later. I will simply put an exception here. So we can say ignore dependency, and now it expects from us an origin and a target. So an origin is this exception controller aspect, because this is the one that calls binding errors response. And let's try to do this now. I know you might be, your eyes might be bleeding because of what I have written right now, but I wanted to show you just one more thing. So please stick with me. Maybe one more idea that you can use is to introduce yet a separate layer, something like a cross-cutting layer, if you use an aspect-oriented programming, so that you can use those advices everywhere. I mean, everything, they can access everything, every other layer. But we can see that it still throws. And this time, the exception message is very peculiar, because the method architecture tests test references binding errors response. So the fact that we have put this binding errors response here makes this test that defines our rule violate the rule that it defines. Yes, this is, I know this might sound pretty funny, and you might be scratching your head, why are we analyzing test classes? But ArchUnit can also be used to write assertions about tests. But we can simply exclude it. You can see this class file importer expects a collection of import options. So I will just say singleton import option. We have some, yes, we have some predefined options. Do not include tests. I will run this one, and it should exclude tests from our analysis. Let's just wait for the test to see if it passes. Hopefully it does. And indeed, okay, there's always a bit of stress regarding live coding. But okay, this is everything that I wanted to show you. Maybe there's one more thing that that might be useful for you, because not everyone works in a greenfield project where it's so nice to write these rules because they are always preserved. Maybe you work in a brownfield project that already exists for a while and those rules are already violated, and you don't want to write those many exceptions. What can you do about this? There is a nice feature in ArchUnit which is called freeze. And with freeze, you can simply generate a file or run a test in a perfect scenario. So for us, it would be like this. I could run this test, and all the violations that it creates, we can dump it into a file that will then be used by ArchUnit to see if there are new violations of these rules. So we can have our pace of fixing the project, refactoring, and so on. The existing failures will not cause our pipeline to fail. Only the new ones. If we introduce new violations, then it will fail. And we can or in our tempo, slowly refactor the project. Okay, so I have just a few more slides of other interesting projects, so this will take 2 minutes. These J molecules I have already mentioned. It comes with a bunch of entities that you can use to document your architecture. Here we have domain-driven design, we have entity, identity, value object, aggregate root, and so on. But also we have some annotations regarding layered architecture. You can see domain layer and application layer, which actually plays really well with ArchUnit. So in this test like we have here, we wouldn't have to use these awful strings or maybe a bit better constants. But to avoid this awkwardness by defining in which packages which layers are defined or reside, we can simply use J molecules to document it in the code and then simply write our rules. There is also Spring Modulith, which I will not talk much about because this is still in experimental phase. But here you can see this is pretty much, this is very similar to what we did. It says, okay, scan everything that is from application downwards and verify. Spring Modulith has this nice structure. If you are building a modular monolith, every monolith has some package that can be accessed from the outside, and only through this endpoint other modules can communicate with our module. So with this we can make sure that indeed this is preserved, this is enforced, and that we don't rely on internals of other modules. Also, it verifies that there are no circular dependencies and our modules form a directed acyclic graph, to be precise, right? But okay, this is just, this deserves a presentation of its own, probably. But this is everything that I wanted to show you. Thank you very much for your attention, and I strongly invite you to ask any questions. Also, if you have any questions, you can also find me on LinkedIn or I don't know. This is the only social website that I have, social media that I have. So you can ask me there as well. Are there any questions? Okay, I believe there are no questions because none are displayed. So thank you again very much for listening to the presentation. I hope it will be useful for you, that these ideas will come in handy and you will find a bit of time to employ it in your project.